Greetings from Texas. This video is a response to Paul McWhorter's class, AI on the Edge. Uh, this is an assignment that was made in that class. The assignment was to ask the user to say a brightness. In my case, I'm going to ask them to say something, say a number between 0 to 15, and use that as a PWM percent. Of course, they'll have to map it to a percentage. We're going to use that brightness in the PWM and display the brightness on a red LED from the RGB LED. We're going to put the speech to text in a thread so that we don't have to in any way wait on a response from the user. Then, of course, we need to kill the thread when the user is done with the program using, when they say quit, in my case, quit. And we're going to also need to kill the thread when the user enters a keyboard interrupt, such as Control C. This is the setup that I have. The LED that we're going to be working with is right. This is the code. The code, the PWM, the speech to text. We're going to use threading, use Q, and we're going to use try and accept. We bring in the different modules that we need with our import. And I'm going to use the red our RGB LED pin 5. You see the other pins there, I've commented them out. We're going to only use the green or the red one. And I'm using a find. So in the string, if it finds it, the spoken number, then we will return the number for that location in the string. So 0, of course, is going to be position 0. And I've spaced them all out so that every one of these takes 10. The bar, Z, E, R, O, and then the spaces to fill it up so that it's 10 characters total. And this is a line continuation right here. Every one of these takes up exactly 10 characters. When you speak a word, you might speak only a letter, such as O or T. And we want to find not just the O, we want to find the 1. We don't want to find just a T, we want to find TWO. So we're going to delineate each word that is captured by putting a bar in front of it. And of course, the word has a space at the end of it. And so we'll put a space on the end of whatever the speech to text returns. We're going to use 16 of these, 0 to 15. We initialize running to true. We're going to use running in our thread. And I'm also going to use an event on the for the thread. And to be honest with you, I'm not really happy with the way we kill this thread, and maybe it has something to do with the speech to text process and the way that it captures something and then pokes it on the string return. I don't quite understand. I've got a demo of what I'm talking about when we get to the point where we're exercising the keyboard interrupt. I called my thread PWM percent speech to text. We show that the thread is started, declare it running as a global so that we can pass it back and forth. You see that I am checking to see if the thread event is set, be the stop event. So I'm kind of using a shotgun here. So you see I'm using run false and break both. I did a lot of experimenting trying to take care of the keyboard interrupt issue, and all that's still in here. I do use if and else. I don't know exactly what the legacy is behind Paul asking or speaking that he does not use else. Uh, this seems to be a reasonable way to do it in my case, instead of when we get a spoken value back, as you see here, if it's spoken value is going to be looked for in the string that we created that have the recognized spoken numbers in it. Spoken numbers, we're using find in there. We're taking the value that was spoken, that was put in the value from the speech to text. We're going to prepare this by starting it with a pipe and ending it with a space, and that way we're actually going to find the numbers, the spoken number, and not just the first letter of a word or something. We got to do some math now once we find this, because we want to get a brightness percent. This math right here is going to divide whatever location the value spoken value was found out, divided by 10. So as we introduced earlier, 0 starts at position 0, 1 starts at position 10, 2 starts at position 20. So if we divide that by 10, we'll get 1 through 15. And down here we're going to do the math. We're going to map and round so that we have a percentage with a single decimal point after. And then we're going to pass that back to by putting it on the Q, PWM percent Q. We're going to put the value on there. If it didn't find our number in the spoken stuff, then it's going to say I didn't recognize your number. Wait for entry of another number. If the user speaks the word quit, then it'll set running to false and break. And I'm not sure which one of these is really giving us the most value. The while statement will cause things to stop when it finds either the event or the running set to false. We have a message that's then displayed. If the when cannot be processed, it's going to drop down through and hit the print and explain that the thread is exited. Some of this is exactly as was seen on, or at least very similar to the way Mr. Paul set things up. We're going to check to see if there's anything in the queue. If there's something in the queue, then we're going to set the pulse width of that LED to that percent. If running is false, as we see here, the comment, if we can't do anything in the while statement, then we're going to come down. We're going to use these events to stop and wait till it comes back to this context. We're going to check to make sure that everything is quitting properly. When the thread is alive, then we're going to report, hey, something's interesting here. The thread's alive. We need to kill it still. So we issue all of this again. So that's a, a confirmation of the thread being killed. Instead of just saying kill it, I'm going to confirm that it's killed. And we're going to try it one more time. If it's still alive, if it's not still alive, the context that we're going to jump to, then we're going to say, hey, we confirmed that it did terminate. Set the PWM percent to 0 and echo that out to the user, and then say that the main loop quit. Notice that all of these basically are space dot, our dot space. When we do a keyboard interrupt, we're going to echo with a greater than between the two different types of messages. And this also checks to see if the thread's been killed. If it's not been killed, then it echoes it back that it is still alive, even though it tried to kill it. If it did kill it, then reports back that it confirmed that it has terminated, and there's the end. Got the shell window open up so you can see. Let's press run. Say a number between 0 and 15. 15. 1. 0. 15. Quit. That looked the way that it was supposed to. Quit, and we had confirmed that the thread was terminated. Let's run this. 15. Now I press Control C. 1. So it's waiting for one more iteration through the thread. Notice it echoes back the value that it found. So that's and this message starts with a dot. It doesn't start with the greater than. The message definitely came from the thread and not from the interrupt handler. Have a great evening.